Download this code from codegive.com, link in the description below. Direct memory mapping is a technique used in computer systems to map a portion of a larger memory space into a smaller addressable memory space. This technique is commonly used in cache memory design, where the main memory is divided into blocks, and the cache is divided into lines. Each block in the main memory maps to a specific line in the cache. Key concepts of direct memory mapping. 1. Cache memory, a small, fast memory located close to the CPU that stores copies of frequently accessed data from the main memory. 2. Block, or line, the smallest unit of data that can be transferred between cache and main memory. 3. Cache size, the total amount of data the cache can hold, usually measured in bytes. 4. Block size, the size of each block in the cache, usually a power of 2, example 16, 32, 64 bytes. 5. Mapping, each block of main memory is mapped to a specific cache line. In direct mapping, each block of memory maps to exactly one cache line. Address breakdown in direct mapping. To access data in the cache, the memory address is divided into 3 parts. 1. Tag, identifies whether the data in the cache line corresponds to the requested memory address. 2. Index, determines which cache line to check. 3. Offset, specifies the exact byte within the cache line. Address calculation. For a given memory address, the breakdown can be computed as follows. Total address space, \2 n where \n is the number of bits in the address. Number of cache lines, \m cache size /block size. Number of offset bits, \log_2, \text block size, Number of index bits, \log_2, m, Example code implementation. Let's create a simple simulation of direct memory mapping in Python. Explanation of the code. 1. Initialization, the direct mapped cache class initializes the cache with a given size and block size. It calculates the number of cache lines and initializes the structures to hold the cache data, valid bits, and tags. 2. Index and tag calculation, the get_index and get_tag methods compute the index and tag for a given memory address. 3. Memory access, the access_memory method checks if the requested address is present in the cache hit, or not, cache miss. If it's a miss, it loads the block into the cache. For example usage, the example shows how to create a cache and access several memory addresses, demonstrating cache hits and misses. Conclusion. Direct memory mapping is a fundamental concept in computer architecture that optimizes memory access times by using a cache. The provided code illustrates how to implement a simple direct mapped cache simulator, allowing you to understand the workings of cache memory in a hands-on manner.